Good morning or good afternoon or even good evening, depending where you're connecting in from today. Thank you very much for taking time out of your busy day to come listen to a great webinar that's being co-hosted between NXP and of course Crank Software. And it's on creating the IoT devices of tomorrow that are built upon the NXP processors and of course driven by Crank Software built GUI tools, GUI development tools. Just before we jump in, I just want to let you know that today's session will be recorded. So if for some reason you need to drop off or you get disconnected, or maybe you have a colleague that you think would benefit from today's topic of discussion, we'll be presenting it on demand about 24 to 48 hours after today's session is done. Also, we have the benefit of having some live Q&A at the end. So at any point in time, using the question section you find on your screen, please pose your questions. If you can maybe make it a little bit easier, maybe direct it towards the particular speaker or maybe particular to product. That makes it a little bit easier when it comes time for the question and answer period to know exactly what it was that you were talking about. And of course, if you haven't already, feel free to follow Crank Software and NXP on our social feeds. So whether it's through Twitter, LinkedIn, or maybe Facebook. And of course, at any point in time, if there's anything that catches your eye and you want to kind of put it out there onto this, the social sphere, please use the hashtags GUI development or Crank Software or even NXP partner. So as I mentioned today, we're going to be talking about creating IoT devices of tomorrow. So going to get into kind of a brief introduction of who your speaker is going to be and what's really going on in the market. So what challenges and opportunities that exist within the IoT market. Then we'll jump into some of the key aspects to keep in mind when designing an IoT device. So whether it's hardware and how that hardware plays with software and graphics. And then key GUI development capabilities that really help maximize the development of the UI for the IoT device, and what resources can be really leveraged within NXP's embedded systems by our GUI development tool called Storyboard. And then last but not least, we'll jump into the question and answer. So we're very lucky today to have two great speakers. The first is going to be Rob Casaro. He is the IoT Technology Officer at NXP. And we also have Jason Clark, who is a co-founder of Crank Software and is the VP of Sales and Marketing. So with that being said, let's jump right into it. We're going to be kicking things off with the graphics for the IoT market and really kind of giving you an overview of really what's happening in the world today. So I'm going to be passing things over to you, Rob.
Hi, my name is Rob Casaro. I'm a fellow at NXP, and I wanted to discuss graphics for the IoT market. So right now, we're going through what we call the fifth wave of computing. It consisted of, in the past, phase one was mainframes, and then it went from mainframes to mini computers. And then we have, wave three is the personal computers, and then mobile computing. Now we're kind of existing in that mobile computing and personal computing phase, but rapidly approaching more volume is the AI IoT market. We call that the age of IoT, where everything is connected. So everything's connected to the internet, and now that's considered the fifth wave. And that's a huge market. There's a lot of things that are connected to the internet. So NXP has this trend number 6 that we're seeing as well, called the empowered edge, where there are more devices connected in this edge, but connected to a bigger device, and that device is smarter and is collecting data from those edge nodes to this empowered edge, which then gets broadcast out to the cloud. And the reason why we talk about that is it really, if we have this more empowered edge, it reduces latency, improves performance, and just has a better experience in general. So we divide the edge or the IoT as they call it, into three different kind of categories. There's the cloud servers that everybody knows about, then the network edge, which is smart devices that sit in your home collecting data from smaller devices, or the application edge. These are IoT endpoints. And these IoT endpoints are the ones that have the graphics, they'll have more, this is what the user interacts with. This is what the user will see. And this is where we're concentrating our efforts on, with graphics and better devices that have higher performance. So we have 4 different market spaces that we're addressing: personal devices, smart home, devices that control your home, smart appliances. This can be just about anything that you can think of as far as motors and industrial applications, from washing machines to other type of applications. And then also emerging and consumer retail spaces where we get tracking of packages and tracking of what you bought in the store. So there's a lot of new ideas emerging there, even from this idea of delivery drones, dropping packages off at your house, or little drones driving down the sidewalk. So these devices all require more horsepower, a lot more capabilities than there was in the past. So if you look at in your house, there's a myriad of things that are becoming smart, from thermostats to doorbells, to door locks, smart speakers, the Amazon Echoes, and all the different Google devices that you can talk to now. Thermostats can understand if you're home or not. They can set the temperature accordingly to what's going on in the home. You can see what's happening if you have a remote home. You can see what's happening in that house. Lights can be turned off and on remotely. So just from this picture alone, you can see there's a huge amount of things that are becoming connected to the internet. Wearables is a great example of what's connected to the internet as well. There's a lot of people wearing Apple Watches, Garmin watches, Polar watches that collect data, transmit it to the internet. Did I run today? Did I bike today? How long did I exercise? Trying to get people having a better experience with their daily activities. So the trends here now really are longer battery life, because nobody wants to charge their watch every day. They want to be able to have at least 5 days seems to be a comfortable limit. There are manufacturers making these things now, and you want to be able to have smaller form factors. So that's really pushing low power, very low power devices in this space. And also it's pushing low power not just to wearables, but into other devices that are connected, always connected as well. So think about Amazon Echo. It sits in your house. It draws about 3 watts all the time, and we want to reduce that power to less than a few milliwatts, and that's happening in the future. So I wanted to talk about silicon trends. I think that is like, is it the chicken or the egg case? Is like what's driving some of these things? And in my opinion, it's really the idea of technology is allowing the fifth wave to happen. Without this, we couldn't have the fifth wave. So density is still increasing. We're seeing deep submicron processes going from, just a few short years ago, from 16 nanometers now to 7 nanometers, and then down to 5. I know that some devices have announced in the next few months are in this 5 nanometer node. Also, non-volatile memory is also shrinking. It's not as fast as logic-only processes, but now NXP is producing floating gate flash in 40 nanometer. And I think, in my opinion, again, I think 40 nanometer is probably the last node for a floating gate. I know there are some companies working on 28, but other technologies are starting to come on board that have better characteristics like MRAM and RRAM. And those devices can create this symmetrical operation where you can have both reads and writes symmetric. You don't have to worry about the idea of sectors or pages or page arrays. Now you can just read and write directly to those memories. And those have a huge impact, or will have a big impact on graphics, because once we can have larger non-volatile memories in devices, it allows graphics assets to be more readily available. So from this bottom line, you can see this picture, you can see that, yeah, these processors from Apple, this is Apple silicon, is getting denser, but the size hasn't changed. There hasn't been any change in die size so much. They seem to be stuck around 100 square millimeters or so now. And what's happening is there's more and more stuff being put into these devices. They're getting more and more complex, doing more and more things. The graphics on your iPhone now compared to what it can do in the past is amazingly different. So this trend is happening in general purpose microcontrollers as well. And I wanted to contrast that picture from what you saw earlier, what Apple's doing, to what we're doing with our processors. So NXP has LPC parts now in 40 nanometer flash. We introduced those in 2019. And we introduced just recently RT600 and RT500 and RT1170 in a 28 nanometer node. So those products are allowing us to do a lot more in a smaller space. So look at the chart to the right. That shows the feature size of the process and the density as far as million gates per square millimeter. So in a 28 nanometer node now, an M33 is about 0.1 to 0.2 square millimeters. That's nothing. It pales in comparison with the memory sizes. So what's happening is the densities are increasing. We're adding more and more complex IP into these parts. And when it comes to graphics, that's happening, that's accelerating. And that's why we need partners like Crank to take advantage of all that silicon we're adding into these parts. So we're getting more and more hardware, and the graphics, embedded graphics, are getting better and better. When I started at NXP back in 1999, our graphics were considered character-based LCDs. That was really cool back then. And then that moved to RGB panels, QVGA or so, and they use simple display controllers. We used one from ARM, PL110, and the PL111. We thought that was really complex and very cool, very, very state-of-the-art, and it allowed you to raster out of memory, and we could produce pretty cool graphics with it. The PL111 was the latest update that we did back in 2000, and I can't remember when that was, 14, and it added a cursor memory. But now we're adding GPUs with complex display controllers that support different interfaces like MIPI DSI, and MIPI DBI. So the complexity of graphics that we can now have on embedded controllers approaches what you can almost see on an iPhone. It's amazing to see the differences from just a few short years, and process is driving all that. So what does the hardware look like? Well, we have in our more embedded space vector graphics GPUs that support VG Lite and OpenVG, and those are used for rendering. And sometimes for compositioning, the boundaries are kind of blurred there. We have display controllers that can also do compositioning, it really depends on your point of view on what you consider a display controller, but something that can take an image, modify it, raster it, and give it to the display interface is part of the compositioning process, where you can take different layers and merge and blend them together. It's not really doing any kind of rendering. It's just composing what was previously rendered. So rendering consists of drawing lines and applying different shades and colors and different aspects of an object, and then that's blended together and forms the final image in the compositioning stage. But in some of our parts, that boundary between compositioning and rendering is a little bit fuzzy. But again, these things, these GPUs are really complex. We don't even publish necessarily all the registers that are in them. We're relying on APIs to do all the functions, and that's again why we need partners like Crank to be able to understand all those details, so customers don't have to, so they get full advantage of all of the hardware we have in our parts. I think one story I have about rendering and compositioning is we've had customers using our parts, and we expect the power consumption to be a lot lower using a graphics engines than having a pure software GPU. And in some cases, we've seen, without a specialized knowledge, the power consumption is not too different. So really understanding how to use these engines and using these compositioning components allows you to really get higher frame rates and lower power. So once we worked with this customer to really understand how the hardware worked, they were able to achieve about a 50% reduction in power consumption and also improve performance. So their frame rates went from like 30 frames per second to 60 frames per second with half the power. So these hardware interfaces, these hardware elements that we're providing have significant impacts on power and also performance. So for RT500, which is a part we introduced, had introduced, is going to be in the market in the next few months. It has the VeriSilicon GC Nano Lite, which supports OpenVG, and then we have the RT170 that supports VG 1.1. And with display controllers, we have one that supports, in RT500, supports dithering, gamma correction, also has some cursor memory. And then in the RT1170, we have a pixel processor as well that has many layers that we can composition. It does rotation as well as provides different aspects of blending. So we also have the display interfaces. RT500 supports MIPI, DBI, and also DPI. And the 1170 has different, it has an LCIF, but does support still MIPI and also RGB interfaces. So besides having really great graphics engines in our parts, I think another really important factor is looking at the architecture of the subsystems and how they can get access to memory, because graphics are very memory intensive hardware elements. So in RT500, as an example, we have 5 megabytes of unified internal memory, and all the cores within that part, we have an M33, we have a Fusion DSP, and we have the GPU. They have complete access to this unified 5 megabytes of memory, and it's up to the user to decide how he wants to partition that memory. So we can apply some to the frame buffers, and also we can expand that out into external memory using what we call flex spies. And so those flex spies can interface with NV memories like quad SPI flashes or octal SPI flashes, double data rate, and also PS RAMs, and operate up to 200 megahertz double data rate. So you can put your graphics assets and your frame buffers externally if you want to drive large displays, and if you wanted to have smaller internal smaller displays, internal memory works just fine. So you have this option and flexibility with these parts to have significant memory externally or a fair amount of memory internally to support your graphics assets. So, and the other point I want to make about this is that we have direct access from the GPU into both the internal memory and the flex IOs, and we avoid contention from the M33s or the DSPs. So we have full bandwidth to all those memory assets. The same goes for the RT4 digits. In this one I'm showing there's a PXP and an LCD-IF. So that PXP is doing the compositioning, and that can be done directly out of external memory. It can be done out of internal memory, or it can be done out of these quad or octal SPI flashes. And then at the same time, the LCD-IF can be rastering out of the different assets. So you can modify or change how your system performs depending on your use case, and to get optimal performance. So to get those ideas of 60 frames per second, you have those memory assets to do that. So now I wanted to hand it over to Crank to talk about their software and how it interacts with our hardware.
Awesome. Hopefully everybody can hear me fine. So I'm Jason Clark. I'm the VP of Sales and Marketing. I'm one of the co-founders here at Crank Software. So pretty excited today to talk about how we take the NXP products and help our customers come to life. And so it's really exciting area of what's happening in the marketplace these days. So we'll talk through that. So just quickly about Crank Software, if you're not familiar with us, we are a graphics company. We're built on many years of embedded engineering, and we are built from the ground up for the embedded market. So we are not a when we built our Storyboard product and everything like that, it was totally focused on this embedded market. We are located in Canada, and lately we've been winning a lot of awards from industry and from our partners and from press, just about all the exciting things we're doing in innovation inside of the graphics areas, inside of how to leverage and take advantage of all the power that people like NXP are providing us. So if you're not familiar with Crank, you may have interfaced with us. We're lots of different customers around the world. Touchscreens you're touching every day. This is really what we focus on, is how to help these customers bring these rich interfaces to life. So they have graphics design teams, marketing teams, everybody coming up with new concepts and ideas for new products, whether in sort of our standard markets that we've had for a long time, or new markets such as wearables and the IoT edge devices and stuff like that. There's a lot of interesting stuff going on, and this is where we're running across all of these different markets, because when you think about it, they're all having the same issue. They all need to be able to bring their stuff to, they need to bring this rich user interface to life as best they can. And it's not a unique problem. Before it used to be industrial and medical devices, they had this very archaic look, but now everybody wants to chase the feeling they have on the iPhone or their Android phones or whatever. That experience is expected. When a customer touches a touch screen, they come in with an expectation that it's going to have a feel, it's going to scroll, it's going to do different things. And they don't have context awareness of the type of hardware that's underneath there, or the price points, or all the technical considerations you guys had to make. So it's probably not a fair assumption, but it's one we have to live with. So it's where we're going to talk about today. So Crank Software, the company, we have support and we have product and services to help you do all these things, but our flagship product is our Storyboard development environment. So this is a development environment that makes it faster and easier for design teams and engineering teams to work together to create a vision of a rich user interface on an embedded device. So this is where we focus, this is where we spend our time, and this is what we like doing. So we love to take things like how Rob was talking about, all the hardware that they're presenting to us and all of these advantages, and make them available to our customers in a nice, easy fashion. So Storyboard is our development environment. It runs on Mac, Linux, and Windows. It can develop across multiple different backends. It has a lot of pieces to develop for MCUs all the way up to MPUs, so we can go right from the bottom of the RT series and even some of their older platforms, the LPC series too, all the way up to their most complex multi-core, multi-GPU systems, and leverage either whatever backend's behind it. So, and where we really focus with Storyboard is making it so the design team and the engineering team can work in parallel to drive the the UI faster and better to end product. So taking what Rob talked about there in the market, there's a lot of stuff happening inside of there. And as I said, you know, when a customer touches a touchscreen or touches glass, there's an expectation immediately, and the consumer products are feeling it more now than ever. There's an experience set out right from the beginning that, you know, they're trying to match that cell phone experience, all those rich interfaces they've touched before. But, you know, if I'm making a coffee machine or something like that, I may not be able to put that giant GPU on there to give that same experience. You know, it's not a fair comparison to compare my cell phone processor and memory and requirements that they were able to use to leverage that experience when I'm making a very cost-effective price. So that's where we come in to take advantage of all these little advantages that our hardware vendors are giving us. So the hardware technology is constantly evolving, so new stuff's coming out. You're getting more, but with more, you know, with great power comes great responsibility, but it comes more work. So how do I take advantage of it, as Rob put it? And the other issue that's coming is it's such a competitive market that the product timelines are shortening very quickly. So, you know, people are trying to get to market as fast as they can. So it's a perfect storm there, you know, high expectations, evolving hardware, and short timelines. So this is just making a great spot for, you know, there's great opportunity, but there's hard work that has to come with it. And how can we make that easier and better for our customers is really the big question, you know. So I thought today I'd talk about a customer story that we just released in the last month or so with one of our customers that is one of these devices. And so when I was thinking about what to talk about here, I thought, you know, this is just a great opportunity because Dometic, which is a company that's really focused on making outdoor living easier, I believe is one of their taglines, or they do so much in the outdoor living space with coolers, camping, RVs, everything like that. They were coming into a new marketplace with this new device that they chose Storyboard on top of the NXP RT series, and, you know, they got to market in record time. So I'll talk through some of the quotes they talk about, and the customer story is on our website. So if you want to go check it out later, you can find it there. But so they made it's called the Dometic Interact solution, and it's a multiplex system. So you see the Mercedes RV up there, and inside that there's probably like 3 or so displays, and I'm probably going to undersell it. So if you're actually interested in touchscreens and RVs, I would recommend you go to the Dometic website and read about it there rather than my sales pitch on it. But basically it's a controlling panel, so an IoT end device with a display that allows connectivity across multiple and control multiple things from your climate, your lighting, your water heater, your pumps, and everything like that. There's multiple in them. They have to work on a network. They have a mobile app connectivity. So they had everything that's going on inside of what you're seeing at IoT end devices. They also have to work Wi-Fi-less and in a connected solution, just because, you know, you're not always connected when you're in the middle of the wilderness. But, you know, they had a lot of unique problems there, and they had to bring them all together. So when we started talking to them, had to bring a product together, and this is a sort of a new market for them. You know, it's like many of our sort of IoT edge device customers. A lot of them, they didn't have a display on their device before, but the evolution of their products and keeping pace with the market and showing innovation, they're putting displays on these devices where they may never been. You know, it may have been all hard controllers and buttons and stuff before, and now they find, you know, they can give so much more feedback, much richer look and feel to their customers, and more power and options to control the settings and everything inside their systems. But at the end of the day, this was a new area for them with all their great products they've done in the past. Touchscreens on top of embedded systems wasn't their area of focus. So they needed to make a solution that get them to market fast, because they needed to do that in a very short timeline. And they talk about some of that in some of the quotes that we have here. And, you know, so they were feeling this pressure, new market, short timelines, and, you know, if they kept outsourcing all this work to other companies, it was very cost inefficient, because it was so expensive every time they iterated and dealt with different pieces like that. And underlying all of this is, you know, when you have all these different pressures, is always the performance of the system needs to be there, because if performance is low, you end up just draining your time debugging the issue and trying to sort out performance issues, and that just crushes your time to market. So how Storyboard helps, this is really our three fundamental pieces that we do. We accelerate development. We make it very fast and easy. We have a great workflow that helps our helps our users and customers get to market faster. We built the system understanding that UIs iterate. There is a lot of feedback that comes in, and we have to be flexible enough to go to systems, leverage new different hardware, allow people to scale, whether it's across a product line or just inside their system to have different LCD views or resolutions. So jumping back to Dometic, this was the first quote that really stood out to me. When we talk about accelerated development, I'll talk a little bit about how we help them. We couldn't have created our new product in 3 months without the speed to prototype capabilities of Storyboard. We were up and running fast and made key decisions with prototype feedback. So I don't believe they were at market in 3 months. It's probably just a little bit longer, but they had to get to their first trade show, if I remember reading the article right, in 3 months. So they decided to go forward with this product, and they needed to show it at one of their major trade show event. 3 months, they needed to get up and going super fast. So they were able to leverage, NXP's RT series platform and Storyboard coming together. And we'll talk a little bit about that after, how you can do it yourselves too. So how does Storyboard help with that? So Storyboard is really built to go super fast with a lot of things. A lot of these designs, they're starting in things like Photoshop and Sketch, and we pull that content directly in right away. We make it very quick and easy to animate and start getting feedback immediately and push it to hardware. And a lot of our competition, everybody talks about, faster time to market. We help with faster time to market. Well, everybody's helping with faster time to market. Yes, using any tool is better than using nothing. However, I don't think people always fully understand the order of magnitude faster that we're talking about. So in many of our presentations, and I'm not going to do a demo today, but there is tons of videos on our website, you can see how fast, where we can actually pull in Photoshop files, start adding behavior, animations, connecting screens very quickly and easy at a high level, building rich animations, and push it immediately to a target to see. And that speed to target is so valuable, because until you see your UI running on the system it's going to run on, you don't really have a full appreciation for how does it look with the LCD I'm using. Does the animations I created have the performance to run? Is the user experience what I think it is? Because it's never until you touch it in the real form factor that you really understand how that experience feels, and is it going through. And you can start collecting feedback and such on. You can start collecting feedback on the different opinions and different things coming at you from different sort of stakeholders inside of the system. So all that comes really fast, right from the Photoshop import. I'll talk a little bit more about how we manage iteration in there. And one key part that I wanted to hone in on that is the animations, because this is where so much of our UIs are these days. I have customers all the time who come to me and they say, well, my UI doesn't have animations. Well, it does, because when they hit a button, they want a little pop. When they hit a window, it slides in, maybe it's not what they think of with it's not an animated UI, but this is what you're getting inside of those cell phones, the apps. When you touch your cell phone, you touch any button, you'll notice there's a micro interaction that happens, a little animation that pops. And those animations are what give it a rich feel. So you can do very small, like on a small form factor, a small MCU, and just do a lot of little animations that are small, aren't too taxing on the processor. And if you have a 2D optimization, talk a bit about that in a minute, they're very easy to do and eat up very little CPU. So a lot of people are so worried that if they're on a small form factor because of memory or because of CPU performance, they can't actually do these things. But those are the things that make it feel, those small animations, and the detail that designers can put into those to make them feel rich. In the old days, we used to just flip an image to go up and down. So somebody hit up on a button, they would go up, and then you go down and switch images. And then maybe now we put a little pop, like a little fade or alpha blend. But now they put like rings that come out, and there's this subtlety that the designers can do that gives such a rich feeling when done properly. And these micro interactions really give you know, whether you're doing a very cost-effective price point with a small MCU, you can still offer that rich feel. So, and you can control it and make sure that the animations run exactly, you know. And so an animation timeline tool is very powerful, because if you want to have design teams and engineering teams work together, you need to talk a language that's similar between them. And they, you know, have a, you know, the design team using different tools like After Effects and such to define their animations, and then have the engineering team use code and syntax to define it. You know, when there's a mismatch, it's really hard for them to have a conversation together, because, you know, they don't combine the two. You know, and with our animation timeline, we make it so the designer can actually just sit down and tween the animation himself to make sure it's perfect and exactly as they want it to run, walk through the frames each step by step, and bring all those things to make sure it's exactly what they want, rather than this long feedback cycle of going back and forth between design team and engineering team saying, no, that's not quite it. No, a little slower, a little faster. And, you know, the engineering team's trying to use some default blocks of code that they found on a, like, you know, a JavaScript library or something like that. So these things, when you're using small devices, you know, people always think I bring up the animation timeline and I sort of dwell on it a little bit, because, you know, even when you're using a small device, you're going to have a few buttons or very simple interactions, because the smaller device, it is a very key thing to do, and you're seeing it on your watches and everything. The little pop when you touch it, when you scroll, everything, those are very important pieces. So, you know, now you have a device, you got Storyboard, you've imported Photoshop files, connects to devices, you're running on targets, and you're looking at it. The next thing you have to deal with, it says here, embrace iterations. But really what you're embracing is opinions. You know, everybody has an opinion. You know, you're going to get user feedback. You're going to get feedback from your different stakeholders all through the company. And, you know, this is a great quote from Dometic. In the past, adding features to our UIs was time consuming and cost up to 100,000 per iteration. Now with Storyboard, we're able to add features more frequently and incorporate design feedback faster because of its design flexibility. Design iteration can be expensive. It can be expensive for many reasons. It can be expensive because you're going back to the graphic designers. Design teams aren't always cost effective. You know, engineering teams, sometimes the design iterates enough that it causes the code to have to all be written again. It can cause large gaps in getting to market. And I've seen it so many times with the products we've worked on in the past, where a company, they take so long to actually see the UI on the device that they're so close to the release date before somebody can actually give user feedback, that when they get the feedback, it could be very constructive and very powerful feedback to help them build something. But they're so close that they have to make a decision either to delay the release of the product or just ignore the feedback. And, you know, or sometimes they take a little bit of the feedback and do whatever they can that's easy, you know, and you end up releasing with sort of a compromise solution. It wasn't your ideal solution. And, you know, because the sort of IoT edge devices are moving so fast, and there's, you know, a lot of them are going right to consumer. You know, it's not, you know, it's touch screens inside of your homes on thermostats and different people. It has to work with the average user and making sure that usability, that UX experience is there. You know, it's very important. So Storyboard, we have done so much work to do this. And so some of the things we have done is, you know, I talk about how at the start we can import a Photoshop file. Well, one of the really cool things that we do is we'll re-import that Photoshop file. So if it goes back to the design team, they make a bunch of changes. This isn't a restart over, I have to do a ton of code over again. This is simply say re-import the Photoshop file. We'll more or less do a compare and merge of that Photoshop file into your project. So it'll say, okay, these images have changed, these things have changed positions, these ones are new, or these ones have been removed. And you can actually merge in Photoshop changes in minutes. And it is no rewriting of code, no doing anything. You know, then you just need to validate that your animations and everything still work exactly as expected. You know, so there might be some fine tuning if things changed large position wise, but for the most part, most of our customers are able to just bring in a new Photoshop right a while. The other thing is, when you work in such a graphical tool that designers and engineers need to work together, you need to be able to sort of compare and merge and have the tool sort of go back to where the engineering team works together, which is a code repository usually. You know, many of the systems, well, how they deal with that is syntax. So they say, oh, we push all our stuff, you know, if they're a code generator, they generate all the code, and then the engineer merges that code. Well, if it's generated code, chances are the engineer doesn't always know exactly what that code's doing, because it's the value of the tool. If they knew what it's doing, they wouldn't need the tool. And when they merge, they don't always realize that they could be trouncing on somebody or what they're doing. With Crank, what we did is we took it up a level, and we actually do a merge at the tree level of the architecture. So when we import a Photoshop file and everything, the architecture of our system still looks a lot like, you know, screens, layers, controls, and such going down. And we actually merge at that tree level. So when somebody's doing a merge, they see the tree, they see what's changing. But even more powerful than that is they see a graphical representation of the two of them side by side. So I took a quick little screenshot here. It's probably not the best sample, but you can see the screen change black and stuff. But people don't always realize that they changed an image and who it's affecting and what it's causing on other screens. So you'll actually see inside of Storyboard what other screens might be affected by that, and how I can look at it and see the differences and make sure what I'm doing. And this means that somebody who's a bit more of a visual person than a code person can actually make changes and commit them into the repository for the end engineers to work with, you know, and control that and play a sort of vital part inside of there, instead of just the design team talking to the engineering team, telling them what they would like to see happen, and then wait a day to see if what came out looked like what they were expecting and say yes or no. So. Now, last one was UI flexibility. You know, this is very powerful. So UI flexibility can mean a lot of things, but we look at it as just being able to go where you need to go with your solutions, and Storyboard does offer that. So this is another quote from Dometic. New market opportunities have opened up for us as a result of being able to add functionality and innovate faster with Storyboard. So, you know, they need to go to a bigger processor to make a bigger screen, try new things, add new features, collect feedback really fast, or, you know, make a custom solution for an end customer. You know, we help with those ideas and help them do it quicker and not have to sort of start at square one all over again. So you're able to actually leverage what you've done and move it forward faster. So we do give a scalable solution that goes across multiple platforms, hardware vendors, you know, different software layers, whether you pick like QNX, WinRiver, Greenhouse, Linux, Android as your platform, or the smaller ones like FreeRTOS and ThreadX and such. Doesn't really, we can leverage all of those, and we give you the ability to not have to think about your UI so much when you're trying to select which way to go. You need to scale up or down. So, you know, maybe you have a series of products and you're going to have a sort of a low, medium, and high, and maybe on the low you're going to have an RT series. In the middle, maybe you have like a i.MX 6UL, and at the high end you have one of the brand new i.MX 8s with a ripping GPU core. You know, to give that sort of product line match, you can use the same tool and go everywhere you need to go with that. You know, we can cover you completely wherever you're thinking you might have to go as your product scales up or down. The products change. But coming back to what Rob was talking about earlier, managing complexity is things. As he mentioned, you know, the hardware vendors are giving more and more inside of what they can fit inside of that processor or MCU, MPU. And Storyboard is going all those different ways. So, you know, we can go up and down to match wherever you need to be. You know, if you're going to be on a small processor and there's no optimization, you know, we can just do software rendering. We can leverage the QSPI interfaces for RAM that can help you like save on a lot of RAM space with your images and get you up and going instantaneously. If there's 2D optimization, you know, on the NXP chain, they have a lot of different 2D technologies that are really powerful. We can leverage the G2D, the PXP pipeline, the VG Lite. If there's multiple hardware layers, we can posit those. Hybrid rendering is something awesome that we did on the 7ULP, where they had G2D rendering and they had a 3D GPU, but the 3D GPU pulls more power. So when there wasn't 3D content on screen, we could actually, on the fly, switch over to the 2D GPU and actually draw less power in those for those devices that need to be very power conscious, but still wanted to have the power of a 3D GPU And then as we keep going up, you can have a 3D GPU multi-core. We can manage FBX files, 3D models, everything that you would expect to have. So, it's a single tool that provides a chain all the way up and down for your system to manage. So, we take care of that complexity. So a lot of that stuff where, Rob was talking about, there's a VG light, and then there's the PXP, and then there's how you go to screen. We take care of all of that for you, and it just becomes transparent, and we give you the advantage to just deal with it and manage it. So, if I have customers before who actually built something on a software render only possibility target, and then they switched to using something that had a 2D optimization or a 3D GPU, all they did was change the version of Storyboard they're using. Their app worked exactly the same, and all of a sudden it just leveraged all the performance gains, and it was immediately accessible to them. So that's all I wanted to cover today. We'll throw it, I'll give back to Scott in a second here for takeaways and such like that, and we'll have a Q&A session. But if you want to learn more about any of what we talked about today, you can always visit the NXP site at the i.MX RT link to find out more about their processors there. It is a very compelling product line. The power that's coming out down there, it's one of the most exciting areas we're seeing right now in our marketplace. Just because for a long time MCUs were always seen as simple UIs, and if you wanted to do anything rich, you had to go up to an MPU, run Linux and such, where now they're really making it so what you can do down there, the power, the 2D optimizations, there are 1170 processors running 720p screens, so people always think you had to use a little small screen if you're using MCU. They're sort of breaking all those rules that people have thought in their head for so long. That everything's transforming down there. So it's a very interesting area, and we're really excited to be working with them. We're completely integrated into the MCU Expresso SDK. So if you have their MCU Expresso products, you can actually install the Storyboard demos right out of there and run them immediately. And if you want to try our tool, definitely come to our website and check out our free trial section, and we give you a 30-day no questions asked eval of our tools, so you can try out, and kick the tires and get a good sense of how everything's coming together yourself.
Perfect. Thank you, Jason. You took care of all the key takeaways there. So, so let's jump into some of the questions that got posted. And I know a lot of the questions that came in were about audio connections and the slides. Definitely, as I mentioned, that the final recording that we get back to you guys in the next couple of days will have all the audio enhanced, so that way you can actually hear all the great things that Rob was passing along to you. So, but the first one is, I believe for you, Rob, it is how is minimizing the size of gates on silicone may affect reliability of processors?
Yeah, that's a good question. So yeah, as the gate size shrink, there is an impact on I wouldn't say reliability is an issue. We do a lot of testing, and it's not like you're not going to get any the scan testing and bridging and all the kind of structural issues. Those are all taken care of by scan at speed scan testing or scan testing. The thing that is not a worry, but something that we deal with is aging. So aging has more impact on smaller gate sizes than the larger ones. So what will happen is you'll see speed reductions as the part ages, and then also certain effects of duty cycle and things like that. So we take that into account when we do our designs, that we add a certain amount of margin for aging. So I think that's something that is taken into account as far as reliability. Then there's also this other idea of single event upsets or kind of alpha particle issues with memories. And we at NXP, we look at that quite carefully and choose process nodes that have less impact. So if you look at SEU effects on 28 FDSOI, it's like significantly less than even bulk, because you don't get that backscattering from the bulk layers. And also, we're moving to FinFET. Most of the newer stuff is going to be in 16, 14 FinFET, and FinFETs also don't have that backscattering issue. So if you look at like I forget something like 200 to 100 events per memory, it's an order of magnitude less than bulk. So I think so we worry about that stuff, and I don't think that it'll affect your products. We think about it beforehand. So that's the answer to the question.
Perfect. Have another one for you, Rob. What is the future of electronic paper, like used in Amazon Kindle in IoT devices? Should we consider them in future design?
Yeah, that's super interesting. I really like the idea of Epaper. We have many processors that have EPDC, or electrophoretic display controllers, in them, and it depends on the size. Smaller ones are kind of SPI based, where the display controllers it's in the panel. But yeah, I think they're a really interesting idea. The only problem with EPDCs or electrophoretic displays are a little expensive. But yeah, they're really interesting. I mean, you don't get the frame rates necessarily, but they're really interesting. Yeah, I like those displays too.
Perfect. Another one for you. What is your opinion about headless IoT devices, which can be controlled from them? For example, smartphone with special application installed. Can this approach be relevant?
Yeah, that's a good point. You're seeing a lot of, smartphones definitely have a lot of capabilities to control things. So it really depends on the application. Some applications are fine with that, and others you would like to have a display display on the mic. And it really depends. It depends on
we see it across a lot of different ones nowadays.
Yeah.
And it's sometimes there's multiple of them, and they don't want the display on all the devices, but maybe one.
Yeah.
But it's what we're seeing a lot with the customers who want to put a display on them. It's like, a lot of people are always asking, will voice be the way to go? Or will my cell phone? But we're always finding as customers, and from at least the people we're talking to, is the end customer wants all the solutions. They want to control it from their phone. They want to control it by voice. And when, they're in a noisy room right beside the device, they want to touch it and control it. And, it's not always the best answer, because that just means, I got to do everything. But we're seeing a combination of all of them. There are definitely devices that don't require it. That's going to be your own market research.
Yeah, and also too, I think one of the points that was brought up, like on our silicon, we can make really interesting displays now. I mean, it's not like you can't do that. So you can create cell phone-like displays on these smaller gadgets, right? That are really interesting. So it doesn't preclude you from making interesting display options either.
And the other interesting thing too is sometimes it's not always that 7-inch touchscreen that you have to put on your device. Sometimes it is something like the size of a watch, and all it's doing is giving feedback to the end user. And maybe they are controlling it through voice or different pieces, but they're still looking for some visual cues that,
Yeah.
I told it to turn on my oven. Is my oven on? What?
Yeah, I don't think my wife would like to have a washing machine that doesn't have a display on it. I think that would piss her off.
Yeah, sometimes when you're standing beside a device, you just want to touch it. It's like, why? Or your kids are yelling and, voice doesn't work. The problem is that all these interfaces, there's gestures too. There's all these different things that are coming, and, they're all great. And it's never one is the optimal for every solution. You really have to look at what you're making and what you're doing. So.
And then building upon that, I've got a question that's kind of a thought leadership kind of for you, Jason, is that even having good graphics, it is still possible to have a non-intuitive UI, which might not work well for users. So are there any systematic approaches to this problem nowadays? Bit of a loaded question there.
Yeah, no, definitely. We help our customers realize their UI vision, but if they have a bad vision, we don't control that idea, so to speak. But the way we look at it is, the faster you get that on target, and that's how fast. And I've had customers who said, we had a marketing brainstorm one day. Somebody put together some quick Photoshop files. We put on a target, and then we actually ran through the ideas and concepts really quickly to see if they worked. that speed and trying something on a real device very quickly and getting that feedback early, I find where people usually get into troubles is, you know, people know when it's a bad interface. People know when it's just not good. But if you don't get that feedback, if you're at a point where when you gather that feedback, you can't do anything about it, or it's hard to do something about it, that's what will cripple you from acting upon it. You know, everybody's more than happy to give you opinions on why your stuff isn't good. You just need to like be able to leverage it and take advantage of it. So yeah, it's we do have a lot of the things that we do inside of our system, like push you to a clean architecture where we separate the UI logic from the business logic, and this makes it a lot easier when you do need to iterate your design because you're not so worried about how it affects the underlying logic. And if you do a nice clean architecture in there, that really helps. But you know, feedback on an interface is always one of the best things.
Yeah, so definitely, you know, building upon what Jason was saying there, I was going to mention some of the same things as well. But we are also in the process of developing some guides to really help you when it comes to you know, implementing your UI at different stages, whether it's at the prototype staging, to the testing stage, the building and collection, stuff like that. So you find those best practices guides on our website going forward over the next several months as well. So something to maybe to loop back upon and take a look at. I got one for Rob. Rob, is 5G going to play a role in connected IoT devices? Like, how big of a role do you think 5G is going to play?
Oh yeah, I have my own opinions on that, which I find interesting. So, yeah, I think so. I think definitely, you know, 5G will have an impact, and I think there's like these low data rate options. For me, I always find it funny that why do I need a Wi-Fi to turn my lights on and off just because that was a standard? You know, it's like, really, I have this thing that has super high bandwidth, just turn a light off and on. So I'm hoping one day that we'll have some low data rate ideas that'll become more of a standard. And I don't know which that's going to be. And 5G, I think, has some emerging standards that will be part of that. So, you know, I'm hoping that, because like to turn your sprinkler on and off, or it's like, why do you need 5G? You know, it doesn't make any sense. But yeah, I think there will be definitely that's going to be, you know, this ubiquitous wireless landscape is happening. Yeah.
On that note, I remember reading an article recently talking about Flutter and Fuchsia and the future for them, how they're going to play then maybe potentially the next big thing when it comes to cross-platform support for IoT devices as well, being created by, I believe it's by Google. So, you know, really kind of maybe having that kind of that standard, going back, you were talking about the de facto kind of development platform. Here's one that's supposed to be able to cross Apple to Android to
Yeah.
any of the devices, so even embedded, to allowing you to kind of maybe the future of embedded being kind of maybe born upon that as well. It's also an interesting thing, but it's very now at the young still emerging phase that it's still kind of being developed. But you know,
yeah, that's a whole other interesting topic about embedded operating systems and trying to create a standard for that. That's been trying to happen for a long time, and big companies have been buying smaller, like, you know, FreeRTOS was acquired by Amazon, and ThreadX was acquired by, I think it was Microsoft. So I don't, but then once they get acquired, the embedded guys don't like it anymore.
Fair enough. Fair enough. Jason, I have one for you. Does Crank Storyboard support Zephyr? And if not, is it in the plans?
Yeah, it's on our roadmap. We support so many OSs. Honestly, if you're looking at Zephyr, it's not a big issue. We just haven't gone to a full market solution for it today. But the OS doesn't mean to take away from the OS vendors out there, especially on those smaller ones. We don't require too much from them. So Zephyr has everything we need. It's just we haven't put out a standard offering in the market yet based on it. You know, we pretty much have every other OS, but Zephyr will be probably soon. And yeah, if you're interested in it, let us know, because operating systems, as you see how many different systems we support, we are very portable. So it's not a big concern when somebody says, I prefer to use this OS.
Yeah, definitely. So building upon what Jason said, that you know, if this is something that does interest you and it's something that you know, you want to work towards in your next embedded project, like, reach out to us. You can connect with our team right from our website, and we can set up a call and kind of meet with you on that. So with that being said, that seems to be the last of the questions. And so I just want to say thank you very much for everybody taking time out of your busy day to come listen to both to Rob and Jason. And we look forward to seeing you in our next webinar. With that being said, Talk to you soon. Bye.